Hey everyone, so we are going to continue looking at right triangles, and specifically in this video we'll be looking at similar right triangles that are formed when I drop an altitude. Okay, so an altitude of a right triangle is this segment right here. I draw it from this vertex straight down and it forms a perpendicular to the hypotenuse. So that's what an altitude is. And if I drop an altitude, then the two triangles that are formed, triangle 1 and triangle 2, are similar to the original triangle, which is this big one. And they are similar to each other. Okay, so I think you will be able to notice that best in example 1 when we draw the three similar triangles in the diagram. Okay, so the first triangle is going to be the big triangle. And that would just be triangle A, B, C. Okay, A, B, C, where B is my 90-degree angle. And in the original diagram, there are two other angles, right? Angle A and angle C. So angle A, I'm going to call one swoop. And angle C, I'm going to give two swoops, just to designate all the different angles that are there. Okay, so angle A here, one swoop, angle C, two swoops. Next up, we have this, let me get a different color. We have this medium triangle here. We have that medium triangle. And that's going to be triangle BDC. BDC. And that's got a two-angle swoop at the C because they share that angle C. And then lastly, we've got this small triangle here. That's going to be triangle ADB. D is the 90. Angle A has one swoop. All right, now, remember, similar triangles have congruent angles and proportional sides. So a big triangle compared to the medium triangle, you've got the 90-degree angles that match up and the two angle swoops which match up, which means that up at angle B in the medium triangle needs to be the one swoop because the angles need to be congruent. All right, for the small triangle, you've got the one angle swoop that matches up. You've got the 90-degree angle that matches up. That means angle B in the small triangle is going to have two swoops. All right, I like to draw in my swoops because that's going to help us out with example 2. Okay, so these are the three similar triangles, and I guess I forgot to label the side lengths that we know. In the big triangle, AB is 9, BC is 12, and we don't know what AC is, but we could use the Pythagorean theorem to figure out 9 squared plus 12 squared equals C squared. So that is going to give us 15. Okay. In the medium triangle, we've got the hypotenuse, BC is 12. DC we don't know, and BD is H. And then in the small triangle, we've got that AB is 9. And we've got that BD is H. And we don't know what AD is. And there's no way for us to figure out AD or DC in the medium triangle. So this is where we could set up proportional sides. Since we were able to use Pythagorean theorem in the big triangle, in the purple triangle, and get that to be 15, there are now a couple ratios we could set up. 15 in the big triangle corresponds to 12 in the small triangle, just like 9 in the big triangle corresponds with H in the medium triangle. Okay, so 15 and 9 are the big triangle, 12 and H are the medium triangle. Or we could set up 15 from the big to 9 in the small, just like 12 in the big to h in the small. So this is the big triangle, and this is the small triangle. So I'm kind of getting ahead of myself a little bit because this is what we're going to be doing in example 2. But just to remind you, when you're dealing with similar figures, the angles are congruent and the sides are proportional. So the angles are going to help us figure out what side lengths I can set up in a proportion in order to solve for missing parts. So let's move on to example 2 and let's actually do that. Let's find the value of y in this triangle. All right, if necessary, draw them separately. I think it's always important to start by labeling your angles. All right, so angle F, I'm just going to call 1 swoop. Angle D is 2 swoops in this big triangle here. In that big triangle. So if I need to draw that separately, I've got triangle F, E, D. FE is Y. And then FD is 15. And I don't know ED. Angle F is 1 swoop. Angle D is 2 swoops. So in this chart to the right, this is going to help us kind of organize our information and see what proportions we can set up. So we've got the big triangle, small triangle, medium triangle. Instead of calling it short leg and long leg, short leg I'm going to call the side length opposite the 1 swoop. The long leg, side opposite the 2 swoops. So in the big triangle, opposite the 1 swoop, we don't know what that is, so I'm just going to cross this out. Opposite the 2 swoops is y, and the hypotenuse of the big triangle is 15. Okay, next up, I'm going to analyze the small triangle here. If I needed to draw that separately. Let's see, we've got angle F up here, which is the 1 swoop. G is the 90, and it goes out to E. So since F is the 1 swoop, that's going to make E the 2 swoops. FG is 4. GE, we don't know. And FE is Y. So opposite the 1 swoop in this triangle, we don't know what it is. Opposite the 2 swoops is 4. And opposite of the 90-degree angle, or the hypotenuse, is Y. All right, so we have enough right now to set up a proportion, but I'm going to show you how to set up this medium triangle as well. Okay, so if I draw my medium triangle, the 90-degree angle is G, 2 swoops is D, which means that 1 swoop is going to be E. All right, what do we know? Well, we know that this whole thing, FD is 15, FG is 4, which means GD is going to be 11. We don't know what GE is, and we don't know what ED is. So in this chart, in the medium triangle, opposite 1 swoop, we've got 11. We don't know what's opposite 2 swoops, and we don't know what's opposite the hypotenuse. Or we don't know what's opposite the 90-degree angles. We don't know what the hypotenuse is. Okay? So drawing them separately helps. Eventually, after a lot of practice, you should be able to put the 2 swoop in there and the 1 swoop in there and maybe visualize the 3 triangles in the original diagram. But if need be, please draw those separately and fill out this chart so you can set up the proportion. All right, the proportion that you can set up is right here. Y over 4 equals 15 over y. So that's the proportion that I can set up because y is the side opposite 2 swoops, just like the 4 is opposite 2 swoops. So this y and 15 both belong to the big triangle. 4 and y both belong to the small triangle. And then if I look vertically, the y and 4 both are opposite 2 swoops. and the 15 and y are both the hypotenuse. So your corresponding parts line up. So I can set up this proportion and cross multiply. Y times y is y squared. 4 times 15 is 60. So then if I were to break this down, so y is equal to the square root of 60. Breaks that down into the square root of 4 times the square root of 15. Square root of 4 is 2. Square root of 15 doesn't have any perfect squares in it. So y is equal to 2 square roots of 15. That's that missing side length. Okay? So these can be tricky because there's a lot going on in the diagram. You've got 3 different triangles there, each with missing parts. All right? So use Pythagorean theorem if you know 2 out of the 3 sides. And if you don't, set up this chart in order to set up a proportion to solve for your missing parts. Okay? Draw in your angle swoops, match up the corresponding parts. To finish this out, I got 2 you try now problems for you. So use your notes or pause the video here, try out number 1, and then try out number 2. Okay, the answers are down in your notes for the you try nows, but pause the video and try those out. We will go over them in class. Draw your angle swoops. That's going to help you. So instead of short leg, call this 1 swoop. Instead of long leg, call this 2 swoops. And match up the side lengths there in order to set up a proportion. Let me know if you have any questions, but we will go over this in class. Have a good one.